Bootstrap can be used for pretty much any type of estimate that you estimate. And it's like a pretty general algorithm that just m times you take a Bootstrap sample of your original data set, you just redo whatever it is you were doing. It could be anything. It could be regression. It could be just taking a difference in means, like basically any quantity that you were trying to estimate from your original data set, you just re-estimate it from each of the Bootstrap sample data sets and you save your results. And then you just take the standard deviation of all those results, and that gives you the standard error for the thing you were trying to estimate. So yeah, in class, it was an average treatment effect. And then in the homework, it was a difference in means, but it could be anything. And what's great is that you really don't need to think if you want to use Bootstrap to get the standard error for something, you can just go through this process. And so that's a plus, right? It can be pretty mindless. And also, it doesn't lie. So there are fancier kind of analytic methods that give you standard errors for estimates. For example, the standard errors that get output by R when you do a regression for all the regression coefficients, the standard error column, those depend on the assumption that the outcome is normally distributed around the conditional mean. Bootstrap doesn't depend on that assumption. It's basically assumption free. So I don't know, just a plug for Bootstrap as you keep going forward in life. Remember that it exists, it's really useful, and like you hardly need to think about whether to use it, you can just use it.